Alright, next question. We want to take the derivative of this function. I'm going to rewrite it over here. 5 e to the 7x plus e to the negative x. Well, remember, the derivative of e to the x is simply e to the x, right? But if we have something more complicated in the exponent there, it would be e to the u, and then we would take the derivative of that u related to the x and multiply. So this is a sum, so first we'll work on this part. Well, the derivative of 5e to the 7x is 5e to the 7x, then times the derivative of the 7x, which is 7, plus the derivative of e to the negative x is e to the negative x. The derivative of negative 1x is negative 1. So the answer should be 35e to the 7x minus e to the negative x. Alright? Let's look at the next one. Now this is an interesting one. This took a little while for me to figure out. But in order to use any derivatives from this graph, we first need the slopes, right? So we need the slopes of the different parts of the graph. So for f of x, I'm going to call this part of the line A and that part of the line B. So if we look at the A part, I'm going to pick 2 points off the line. 2, 4, right, and 4, 8. I'm going to calculate the slope. So that's 8 minus 4 over 4 minus 2. So 4 over 2 equals 2. Let's look at the other half of A and pick 2 points. Well, 4, 8 is this point right here, isn't it? And then I'm picking 6, 4. Calculate the slope there. 8 minus 4 over 4 minus 6. That'll be negative 2. And then for g of x, I'll pick point 0, 8, right there, and 2, 6. So the slope would be 8 minus 6 over 0 minus 2. 2 over negative 2 equals negative 1, because we're going to need that in a minute. Alright, so they want us to estimate some derivatives of this, h of x equals f of g of x, of this composite function. Think of it as a chain rule. The first thing we do is we take the derivative of f, right, with that g of x inside, and then we take the derivative of the inside, which is g of x. So at each point here, we're going to plug in what we know from our slopes over here, because the slopes are the derivatives, aren't they? Alright, so let's try h of 2. That means we need to take the derivative of f at g of 2 times the derivative of g at 2. So first I'm going to read right off the graph, what is g of 2? Well, that's 6. Right, that'd be the point there. So f prime of 6 times g prime of 2. Well, f prime of 6 is on the b side, so we use the slope at 6, which is negative 2, and then the slope of g, which is the same throughout, which is negative 1. So this is 2. So that's h of 2. Alright? Now we'll do the same thing with h of 4. I'm sorry, that's h prime. So we want to do h prime of 4 equals f prime of g of 4 times g prime of 4. Now notice, if I look at g of 4, that's actually 4. So f prime of 4 times g prime of 4. F prime of 4, notice it has the sharp corner. F prime of 4 is undefined. So this overall derivative is undefined. Alright, now let's try h prime of 6. So that's f prime of g of 6 times g prime of 6. Well, remember, g prime doesn't change. This is the derivative same throughout. So that's negative 1. G of 6 itself is 2. So f prime of 2. And f prime of 2 is on the positive slope side, which is 2. So 2 times negative 1 equals negative 2. So those should be the 3 answers they're looking for. But really, basically, go back to this. So the key to understanding the composite function is making sure you know how to take the derivative of it. And really, when we have lines on these graphs, the derivative is simply the slope of the line. So we had to figure those out to do this. All right, next. On what intervals, no, thank you. On what intervals is this concave down? Well, remember, we had a problem like this at the beginning. What derivative tells us concavity? Well, the second derivative tells us concavity. So, I need to take the first derivative and the second derivative.
It's too loud to close.
That's all right. All right, so here's the function itself. Notice it's a product. I'm going to use the product rule. So if we're taking the derivative of something that's f of g times, I'm sorry, I'm not going to write it, f of x times g of x, right? Our product is f prime g plus f g prime. So the first derivative, the derivative of x is 1 times e to the negative x plus x times the derivative of e to the negative x, which is e to the negative x, times the derivative of that, which is negative 1. So f prime of x is e to the negative x minus x e to the negative x, right? Notice this is our original function, is it? So f prime, double prime of x. First thing, I'm going to take the derivative of this. E to the negative x times negative 1, so I'm just going to put a negative there, minus the product rule. It's actually going to be this derivative again, but let's just say it. Derivative of x is 1 times this, plus x times the derivative of this, times the derivative of that exponent. Alright, so let's simplify. Negative e to the negative x minus e to the negative x minus x e to the negative x. That's my second derivative. Minus 2e to the minus x e to the minus x. Now, we want to know, in order to figure out concave down, we first want to know the inflection points. So we set this thing equal to 0. Now, remember way back when we did quadratics, and we needed to set everything to 0, I have to change a sign here, folks. This negative and this negative should make a positive, so that's a positive. So we would factor these things, set each factor equal to 0, and that would tell us our possibilities for x, right? So if I factor out an e to the negative x, I'm left with negative 2 plus x. So let's set each equal to 0. Well, guess what? E to the negative x never equals 0. So that won't help us. But negative 2 plus x equals 0. If I add 2, this is my inflection point, right? So I come up, here's my inflection point. I need to determine signs of that second derivative on each side. So let's look at 0, that's easy. And then we can look at 3. So if I take the second derivative now, I plug in 0, e to the 0 times negative 2 plus 0. Well, anything to the 0 is 1, so this thing equals negative 2, doesn't it? So we think the derivative is negative on this side, right? Let's check 3 just for giggles. E to the negative 3 times negative 2 plus 3, so it's e to the negative 3 times 1, when I put that in my calculator, just to check it, e to the negative 3, that's about 0.5. 0.05, excuse me. It's positive, right? So, on what intervals is this function concave down? Well, it'll be x less than 2. Okay? But the key here is you have to take the first derivative and then the second derivative, set the second derivative equal to 0, figure out where the inflection points are, right? This was our inflection point, and then figure out the sign of the second derivative to each side. Okay? Let's move on. Find the derivative of this function. Z equals cosine of 4 theta. Well, we got the chain rule and some trig. So first of all, the derivative of cosine is negative sine, so I took that derivative, and then I take the derivative of the inside of this, which is 4. So negative 4 sine of 4 theta. Hopefully that one is straightforward. Alright, the next one. Alright, here's another derivative. R of x equals 12 minus 7 cosine pi of x. Remember, pi is just a number, right? It's a constant. It's irrational, but it's a constant. So let's take the derivative of this. Well, the derivative of a constant is 0. And then we'll have this thing left. Well, the derivative of cosine is negative sine. So that negative will take out this negative. So I'll end up with 7 sine, right, of pi x times the derivative of the inside function, which is just pi. So this should be 7 pi sine of pi x. Now, maybe I should show all the steps here. So I had this negative 7, and I took the derivative of this, negative sine pi x, and then the derivative of the inside. That's how I got this to be a positive 7x, okay? I'm going to show all the steps. Alright, let's see what we got next. Find the derivative of this function. Again, this function, we have to worry about the chain rule, right? We take the derivative of the outside function and then the derivative of the inside function. So, the derivative of sine is cosine. So w prime will be cosine of this quantity, right? And then the derivative of this quantity. So the derivative of 4e to the t is simply 4e to the t, isn't it? So our derivative equals 4e to the t cosine of 4e to the t. Alright, we're getting there. Okay, here's another derivative. So it says w of x equals 7 tan x to the 8th. Well, the derivative of tan is secant squared x, I believe, right? So first the derivative of the outside function, then times the derivative of the inside function. So this will be 7 secant squared of x to the 8th times the derivative of the inside using the power rule, 8x to the 7th. So if I combine those, I get 56x to the 7th times secant squared x to the 8th. Okay? Alright, let's see about this one. If you fit one more on here. So, f of x equals cosine of sine 5x. We will actually have to use the chain rule twice, because we have the cosine function, the sine function, and the 5x. So the derivative of cosine is negative sine of this function times the derivative inside. Derivative of sine is cosine of this function times the derivative of the inside of that, which is 5. So it equals negative 5. I'm going to move the cosine up here. And then the sine of 5x. Alright, I'm going to stop here, and I'll have to finish any others in another file.